All right, hi guys, welcome back. So we're gonna try the next example here, number 3. In this example, we're gonna find the derivative of this function, and of course, I already gave you a hint that we have to use the quotient rule. But why do we have to use the quotient rule? And we'll explain that in a second. We're gonna argue that because you actually have a function of natural log of x over the function x to the ninth, right? So those are two functions. You're dividing two functions. So therefore, the only way we can find the derivative of this is by using the quotient rule. So let's go ahead and do that. All right. So all right. So we have set up the quotient rule. This is the quotient rule. We have to use it. There's no other option, right? I mean, we could change this to we could have moved this to the top, and change the sign power and use the product rule, right? That would be an option. But either way, you use the product rule or the quotient rule. The quotient rule is better to use at this time because by nature this is a quotient function. So let's begin. So all we gotta do now is execute these two derivatives, right? So it kind of simplify the process if we sort of do this extra step. So begin by taking the derivative of the natural log of x. What's the derivative of natural log of x? It's going to be 1 over x. And then multiply by x to the ninth, right? We don't have to do anything to that one. Followed by natural log of x, followed by the derivative of x to the 9. So the derivative of x to the 9, we can just simply use the power rule, which means bring down the power, leave the x as it is, and then subtract 1 from the power. So that would be 8. All over x to the 9 to the second. Remember what happens when you raise a power to the power? You multiply the power. So that would be x to the 18. All right, so we could think about that. We could simplify these two, right? Because this is 1 to the x times x to the 9. So what would happen here is that these will cancel each other out, right? One of the x's will cancel each other out, so you end up having just x to the 8. So in the next line, we have x to the 8 minus the natural log of x. And we're probably going to move, we're going to move this to the front of it just because we prefer to put the natural log at the end. And the reason is because I think we could get confused if we leave it like this. This would be confused to the reader, saying, meaning, in order for us to tell the reader that the only thing that is in the natural log is this x, we have to put a parentheses, right? So we have to go our way to put parentheses to make it obvious, right? Otherwise, the reader will think that the whole thing is inside the natural log, and that's not the same expression. So that's the reason why. That makes it more clear to the reader that the 9x to the 8th is not inside the natural log of 8. And here what we're going to do is we're just going to carry that over. Now what we see here is we can simplify further, and we should simplify. So big simplify here. This is important. You must simplify, and it's not so bad because if you think about it, there's x to the 8 here. There's one factor followed by the second factor, right? So there's two, sorry, I meant terms. There's one term here minus, and then there is the second term here, right? So there's two terms here, and if you notice, both terms have a common factor of x to the 8. So we're gonna factor that x to the 8, right? And then and factor it out so that we can have now x to the 8, and then if you factor the x to 8 from here, then you're left with 1, right? That way when you multiply it back, you end up getting this. So minus 9 times, if you factor the x to the 8th, then that's gone. There's technically a 1 left behind, and also the natural log of x is left behind. In the bottom, in the denominator, we'll do the same thing. We're going to say, can we describe this? So as a product with a factor of x to the 8th, meaning can you come up with something here so that you can factor out the x to the 8th? And yes, we can. All we gotta do is remember that when we multiply variables, you add their powers, right? So that would give you back the x to the 18th. The reason why we're doing this is because now that the x to the 8th is factored over here, and factor over here, it's a factor of the numerator and the factor of the denominator. Those two can undo each other, leaving behind the 1 minus 9 times natural log of x all over x to the 10th. Right, so this is the derivative of the natural log of x all over x to the 9. All right, and I want to remind you, as always, that this part was the derivative. This and this